Let's go. So we said we're doing this unit in a little bit of a different order because the textbook does a poor job of presenting it. So yesterday we've done 4A and we were just doing the area under the curve calculations. We're going to leave that for a bit. It will pop up later and it is definitely something that we test on, okay, for like 3 or 4 rectangles. It is something we do test. But let's get into the integration from derivatives. So we're making a link here between the function and its derivative. What we learned in all of term 1 is that if I differentiate a function, I end up with its derivative. This is the function, this is its slope function. It tells us the slope for any value of x, and that process is called differentiation. Differentiation gives us the derivative function. So that's the language, okay? Differentiation is the process, derivative is the noun. That's the thing that we end up with. Okay, so similarly, we're going back the other way. We're starting with a derivative, and we're saying, what did I differentiate to get the function I have at the moment? What's the function I would differentiate to get what I have? And that process is called integration, all right? And so this symbol here means the integral, all right? It's like an elongated s, a stretched out s. The integral of some function, and the dx just means with regards to x, okay? Just like up here, d on dx means the derivative with regards to x, the rate of change with regards to x. We're integrating with regards to x, integrating a function. So integration is the process. We sometimes call it anti-differentiation. And so then the function is the integral or the anti-derivative. Okay, let's get straight into it. All we're doing is it says differentiate this and then hence find the integral of this. So we're going to make a link between these two parts. So we're going to have to remember the rules of differentiation, right? Now this d on dx just means differentiate what's inside the brackets here. So if I differentiate this, I'm going to get 4x to the power of 3. All right, take 3. The 3 is going to hang out. The derivative of x squared is 2x. Okay, so the derivative then is 4x to the 3, take 6x. So it says differentiate this, hence find the integral of, okay, whenever you see the word hence, it pops up heaps in the exam. Hence find the integral of 4x to the 3 take 6x. Whenever you see hence, it means using what you've done above, make a link. Okay, so we're asked, what's the antiderivative of this function? That means, what did we differentiate to get this function? Well, we know if I differentiate this, I get this. Therefore, if I integrate this, I will get this. Okay. We're going to tack on one thing, plus c. Okay, whenever we perform an integral, whenever we perform anti-differentiation, we're always going to put on plus c at the end because there may have been a constant here that we don't know about, okay? So that allows for some constant. All right, so that's just always going to be a rule that we follow. Let's go to the second one. We have differentiate cos 3x. Okay, differentiate cos 3x. The derivative of cos 3x is minus 3 sine 3x. Okay, now we won't jump straight to a here's what it wants us to find, right? It wants us to find the integral of sine 3x. This is what we're asked to find. And we don't exactly have the integral of sine 3x here. We need to manipulate this somehow. So the first thing we're going to do is just make an integral statement, all right? That we know the integral of minus 3 sine 3x, all right? If I integrate this, then I get cos 3x. If I integrate this, I get cos 3x because that's the differentiation we performed. Okay, so the first thing we're going to do is just make the integral statement based off of the differentiation you've performed. The integral of this is this. Done. Then we're going to apply this property here. All right? And that's if we have a number, the integral of a number times a function, where k is some number, we can just pull that number right out the front. Okay? So that's going to be our first step. We've got this minus 3, and I'm going to pull that out the front. So we'll have minus 3 integral of sine 3x with regards to x. And here we've just got an equation, and what we're trying to do is we're trying to solve for this part. We're asked, what is the integral of sine 3x? We want that part by itself. I've got this minus 3 out the front, so I'm just going to divide both sides by minus 3 in order to get rid of it. So we'll have the integral of sine 3x is cos of 3x on top of minus 3. And we'll chuck our plus c on at the end. Very good. Okay, that's our second one. We'll go to our third one. We have find d on dx of x squared take 3x to the power of 4. So for this one, we're going to have to use the chain rule. Okay, we have a function to the power of n. A function to the power of n. So when we differentiate it, I'll just plug the chain rule straight away. It's going to be n times the function to the power of n take 1, n f of x, n take 1, and then multiplied by the derivative of the inside. Okay, so I wouldn't expect you to be able to just recall that straight away. And this is probably a good example or a good indication of why we do integration now, because it allows us to recollect all of those calculus techniques that we explored in term 1. And sort of the more we hit them throughout the year, the more they're going to be present for us at the end of the year. So, function to the power of n, chain rule says we go n, f of x, n take 1, f dash of x. Done. Okay, let's make an integral statement. So if I differentiate this, this is what I get. Therefore, if I integrate this, so 4x squared take 3x to the power of 3 times 2x take 3, always with regards to x, okay? We always need our dx for correct notation. All right, if I differentiate this, I get this. Therefore, if I integrate this, I'll get what we had above. So just making a link between what we've done, okay? Integral statement. We've performed the differentiation, and then we're just writing it backwards. Okay, now look what we're asked for in particular. We're asked for basically this whole thing, except without the 4. All right? The whole thing except without the 4. So our first step is to pull the 4 out the front. And the order of multiplication doesn't matter. So it doesn't matter what order we write these components in. We'll put the 2x take 3 first, just as they've done. And we've got the x squared take 3x to the power of 3 second. Create some more space. So we're just using this rule to bring k out the front. Now we have a statement of equality, right? 4 times this integral equals this. The question asks specifically for this component. So we're just going to divide both sides by 4. To get the required component by itself. And divided by 4 or times by a quarter, either of those is perfectly accessible. Okay, so that's what we're starting with today, guys. So it will start easy, it will get progressively hard, and this will be, hopefully we get sort of 4D done before recess, and then we can come back and